I'm starting the recording. Okay, so today's topic is Z specification, which you've already covered during the lecture. And if we have time, we'll have a case on event-based system and even implement it. So it depends on how you will cope with Z. And this is basically the practice for Z. There is a short article which I'm included in the lab in case you want to read it afterwards. It's the lecture examples are taken from this article. It explains it quite nicely. I'll also have the lecture here, just in case, like to make sure you understand, and maybe we will go back and forth, you know, because I want to make sure that you understand the basic concepts. So what is Z? It's a formal specification language. Actually, this slide describes it nicely, right? We go from natural language, which is completely informal. We can try to structurize it. How can we structurize requirements in natural language?
Maybe divide some modules, sections, for example.
Sections, modules, okay. What else? What patterns can we use for natural language requirements? What patterns?
System shell.
System shell, okay. This can be, what else? Very common way. What is a very common way? Sorry?
Software requirement specification.
Okay, software requirement specification. It follows a certain format, right? There is like if something, right? If I remember correctly.
No.
What is it?
Well, it's structured text, which talks about the system, the risks, deployment.
Okay, this is, you're talking about structure of the document. I'm talking about the language specifically. What are the patterns? The most popular way to specify requirements in the industry for Agile?
User stories.
User stories. User stories follow a pattern. As a, I want, so that. It's already not just any natural language, it's structured, right? But we're still in the informal domain. Then you have UML, which is a semi-formal notation, right? It already makes you present your ideas, your specification in a certain way. Then we also looked at OCL, which already, in addition to this visual notation of UML, adds design by contract in place, right? And somehow close to the object-oriented notation. Now we're looking at Z specification language, which is an example of a purely formal language for specifying your requirements. And there are different languages. Z is one of them. There's B, event B, and other languages. So Z is like the earliest of them. It's not much used in the industry, but it's easy enough, and it gives the idea how the rest of them work. Okay. So here we have two parts: set theory and predicate logic. Predicate logic we kind of covered it. Set theory is normally part of discrete mathematics subject in your bachelor. You might not remember it, as it's also fine. So what we want to do, let's skip. Okay, this is all the stuff you've covered in the lecture, so I don't want to be repeating the whole lecture for you. But important things that these are the three things when we're specifying using Z, we will have three things: schemas with the variables where we're declaring the variables. How do we initialize these schemas, and then what operations we can perform on them. And inside of this, here for the schemas, we will have what in addition to variables? Which part of design by contract we will have inside the schemas?
Predicate and
design by contract. Invariance. We can specify invariance using predicate logic. What we will have inside the methods is inside the operations. What we will have inside the operations? Okay, operations are functions basically, but what like, or you mean discrete the set theory functions? Yeah, we'll have functions, but from the design by contract, what do we have there? Post conditions, preconditions. So basically, guys, if you think about it, it makes perfect sense. Schema declares all the variables, all the properties you have, and these are global properties for the whole program, right? for the schema at least. And these are similar to class invariants in design by contract, because schema is, you can think about it as a class. It's one way to think about it. It's also a unit. And you're specifying your invariants for this set of variables. Then you have operations on the schema. An operation is basically a method that you can perform on these variables of the schema, right? And then you're specifying pre and post conditions. So basically, what should be there on the input and what should be there on the output. That's it. This is a specification language. And the way you do it, if in OCL it was close to class object-oriented notation, right? Here it's pure mathematics and logic. Okay. So yeah, that's what I was talking about. That like here you have what? You have schema name and you have this is like your invariant, right? So this is your invariant and these are your variables declared. Okay. This notation you're already familiar with it. Okay, try to explain to me what this is. So Valery, what is this? Okay, so what exactly is this in terms of Z language? So we said, is it a schema, initializer, or operation? There are three things in Z, that's it. Sorry?
Maybe it is schema?
Not schema.
Initializer.
No.
Maybe operation.
Yeah, so like, it is an operation indeed, right? This thing is an operation. So here we are providing the name of the operation. What is this? Andrei?
Variable type.
Variable type? No, it's not.
It says that counter the change is variable.
Yes, so operations are always on schemas.
Okay.
You have schema and operations related. It's like class and methods inside it, right? But I mean, they are not exactly much because Z is not object oriented. But still, you can think about it if we want to attach some familiar. So this we're showing that this is a schema on which this operation is performed. What does this triangle mean?
It changes.
It changes. It's data, right? So it's saying that it's gonna change. So it means we will write. We will write. What does this mean? Only read. This is important, right? Because if we are, whether we're going to change some of the variables in the schema or not, this is important. So now, what are these things? Sorry? No, this is type, yeah, but overall, together, variable. Which variable? Schema variable.
Operation.
Sorry?
Operation.
Operation variable. What does operation variable mean?
Some parameters.
Yes, parameters would pass to the operation. Okay, and they have this question mark. Okay, so and here we're gonna write that. Okay, we're gonna write our pre and post conditions. In that, pre and post conditions are given quite simply. You know, they are given together. You cannot even separate them. The only things that, for example, you have what at this point. At this point, when you are introducing this, here you introduce the operation name, yes? Operation name. So online, guys, I will be switching from board to the thing, and I will try to be moving the camera, okay?
It's okay. Thank you.
Otherwise, I'm explaining that which you don't see. So you have operation, you have schema name here with some sign, right? You have input parameters, params with this question mark, right? This is what you have. So at this point, we have two types of variables. What are the two types of variables? Input, output, which are operation variables, right?
Yeah.
Oh, what else? Schema variables. So we have two types, right? So basically, parameters that are part of this function. And if we had output, we would have it like this, okay? Here we mark what is the input, what is the output. You understand, guys? So like it's basically the parameters and the return type or the return variables. Now, at this point, we have schema variables and the parameters, and we have to do something with them, right? So pre and post conditions, we're gonna limit, we're gonna say, put some conditions on the input parameters, on the output parameters, and on the schema variables, right? So schema variables, for example, here, when we're saying that CTR is not declared here, so it's a schema variable, right? So if we're talking about this thing here, it means it's a schema variable, and it's saying that this input parameter D should be less or equal to CTR. This is a precondition. And then you have this CTR with a dash, with a little dash here. Let me make it a bit bigger for you. With this little, you see apostrophe. So this means that this is post condition. We are basically saying what should happen to the schema variable afterwards. Okay. It's like you're hearing this first time, you know, like you had a lecture about, no? Okay. Okay. And here we're saying for the counter, we're saying that there is only output parameter, right? And output parameter, this output parameter, we are saying that it should be equal to the CTR. So in other words, we're displaying what is the counter value at the moment, right? Yeah. Great. Overall, this is it. I mean, like, obviously, then you can do very fancy pre-post conditions invariants using what? Two things. What we said as the building blocks for that. Because you have to express it using something, right? Sorry? Precondition, post-condition, but what language we will use for the pre and post conditions? And for inverse. Sorry? Predicates. How we will express predicates? Using what formalism? We cannot just say it using natural language, right? Because we want to be precise and formal. What do we use? Mathematics. Which mathematics? Predicate logic and set theory, which is part of discrete math. Okay, great. So you can make very fancy invariants using these two things, okay? Two things. So, okay. Good.
May I ask you, please? Exclamation mark, what does it mean?
Question mark, it means it's an input.
No, exclamation mark.
Exclamation means output.
Oh.
So basically, this is what incoming parameter to this operation or method, right? And this is outcome, like that which has to be output. Sometimes you want to get inside more than one thing and output more than one thing, right? Sometimes you will have both input and output. Sometimes you will have nothing, right? Some operations, they don't take input or output, they just change the schema variables, right? So this is quite close to programming, but not the same. Not the same, because it's not object-oriented. Okay. Okay. So now, you remember medical reserve fund? We're going to specify it using that. Okay, so we will not spend time on counter this and that. Like, we will try to go into this is like still a toy case, but at least a little bit more complex. So you're familiar with it. Here's the requirement, right? Natural language requirement. We're gonna transition it to Z. One thing that I wanted to pay your attention to, which I also noticed is a midterm, and it's a thing that all Russian speakers have in common. We don't have articles, right? In Russian, no articles. So people struggle with logic of articles. With requirements, can be very important. Sometimes you might not, if you don't understand the logic of articles, definite, indefinite articles, you might miss something in requirements. I will give you a super simple explanation to think about it, way to think about it, which is like oversimplification, but it works most of the time. So look here, guys. Let's start from the beginning. Your system should allow a group of people to create a medical fund that will cover their healthcare expenses. Okay? So we are creating this medical fund. A person who contributes to the fund becomes a shareholder for whom the fund will cover future medical expenses up to a certain amount. We actually can start already talking about this. Look, here we said a medical fund. it's undefined. We're saying that some medical fund could be created. Then we're saying a person who contributes to the fund. So at this point, we are talking about that we are referring to specific funds that, okay, we created a medical fund. Now, now we already kind of introduced this variable, right? Now we're referring back to it. So we're saying the fund, up to a certain limit. First time we're talking about limit. We're introducing this variable, right? Now we will refer to it. Yeah, like so, the limit. Okay, so I'm referring to that limit which I was talking about before. If I say a limit, it means I'm talking about again some other arbitrary limit. Okay, so a is like in the but the rule of thumb for you is that if you are talking about something first time, you say a shareholder, and then you're gonna say the shareholder's limit is not reached. So you're referring to that specific shareholder.
So the line we have related shareholder.
It's fine. I mean, like, I'm not attaching it to it. Because I'm saying that for any person to become a shareholder, that's what he needs to do. Then I'm talking to spend the funds as shareholder. So whatever shareholder. I could use the here, it's fine. It's fine. So it's not set in stone that you have to use a first time, because even at this point, you might be referring to somebody you know, to some certain person. But the logic is like this. So if you introduce it, most of the likely you will introduce with a, but then when you're referring to that same thing, always use that. Okay, and pay attention to it. After some time, you will pick up logic. I mean, if you already noticed, sorry, but I did notice that sometimes people get confused with requirements, you know. It's like sometimes also choose from the two, you know, and then we'll say which two, you know. Like, but anyway, any request. So we are saying that there should be a shareholder who can join a fund, and this inside the funds they can create requests, right? And shareholders can vote on this request to be approved. And if it's below the limits, then we can pass straight away to the payment. Let's try to talk about, like, so when we are declaring this Z notation from 0 or nothing. These are some of the elements we'll have. We'll have sets. These are basically types we're working with, right? Then we will have schemas, initializations for these schemas, and operations on, I should say, on the schemas. Okay, this is a mistake, on the schemas. Obviously, I'm not, like, my first language is Russian and Kazakh, and none of them have these articles. So, like, but I somehow learned it. And also on the schemas. So here, what we're talking. First of all, relevant set. Which types are we working with here in this case? Who are shareholders? Some people, right? But if we know that we're going to implement it using smart contracts, right? So what will be the shareholders in the context of smart contracts? Addresses, accounts, right? Ethereum accounts. So we will use here account or address. This is one type of set we're going to be using. Okay. Account. Okay. What else? What else are we dealing with? Requests. Okay. We're going to be dealing with requests, but account maps nicely to address, right? We could even call it address, you know, maybe address is better, you know, meaning that it's Ethereum address. It's basically like a big integer, right? Request is not a type, right? Like by itself. So for request, I suggest making a schema. Okay, so expenditure request. Okay, since we are dealing with, like, okay, I will make it like this, because schema should normally you have joint names, so with camel case. Okay, what other sets do we care about? Sorry, transactions. Transactions. Why? Some operations we should store. But the storing, we don't implement it, right? Votes, okay. Votes. Depends on how we count them, right? I mean, like, what exactly do you suggest? How to, what type does that correspond to?
What's for the request?
I think it's similar.
Okay.
But we can, yeah, what we can do is like a function. I mean, if we already voted, it's like a function of addresses that we can.
Okay.
So we shouldn't somehow say it in sense because it's a function.
Okay. So I think address. I mean, one thing that we have these things which is any request gets approved, more than half of the shareholder proceeds to completion. So any request can be completed or not, right? And I would introduce Boolean here. I would introduce Boolean and declare it something like that it will have true or false. But only two values. Z does not have any values to begin with, right? Like it only has mathematical things. So mathematical things such as set of natural numbers, set of real numbers, stuff like this, right? So I would here introduce Boolean for my convenience. We don't have to call it Boolean, can call it completion, whatever. So this is what I would introduce. The rest, like we will figure out. If we need more things on the go, we will introduce them. For now, that's what we can think of. So there is expenditure request as a schema. What else? Fund, okay. Fund as a schema. What else? Transfer request.
So how much to transfer, for example, to whom?
I mean, to whom is address? How much is amount?
Maybe
Sorry? Voter agent.
shareholder oversees the limit. Other short word was all for him.
Yes, we could do that, but I think like for shareholders, let's attach to address. I think we don't need any more schemas to keep it simple. We are the ones who decide. You can create whatever number of schemas you want. But this I suggest to keep this one because it's simple enough, and the rest just deal with addresses. Okay, initializations. How many initializations will we have?
Empty set or addresses.
Okay, addresses. Why?
Because we don't have.
No. This is a set, right? This is not a schema. Yeah. So this set of all addresses in this video. Okay. So this it's a type basically. We are not given it any value, right? It's anything that is addressed is part of this set. Okay, this set has only two, like the whole thing is only two.
So we should like zero funds for initialization for fun.
Initialization for fun, definitely. We'll have a schema, we'll have to initialize it. Following this logic, we also need initialization and expenditure. So how many schemas we have, that's the number of initializations we have. Simple. Okay. And normally, how do we call them in these initializations? Yeah, this is a convention. So you remember from the lecture, huh? Okay, and init fund. Okay. And what should be the operations on the schemas?
Do we have relevant set as the fund?
What?
Could we have another set as a fund? I mean, from the schema to pass it to the sets, relevant sets. Is it possible?
I don't think so, because the sets should have only basic types, Anything more complex, because fund will have the stakeholders, will have the balance, will have a lot of things, right? So I think we cannot introduce it to sets because it's not basic enough.
But our address, it's address of our wallet now.
Yeah. Yes.
Maybe in a bank or in a Ethereum.
Ethereum,
It
yeah.
doesn't.
Mhm.
It's the, but it's notable too.
Sorry.
I mean, it's not simple object.
Address is a simple object. In Ethereum, it is just a number. It is just an integer, big integer.
Address in Ethereum at 20 bytes value, no?
Yeah,
Holds
I mean,
20 bytes value.
It's a big integer, yeah. But it's still just an integer and nothing else, yeah.
Okay.
So I think it's like 256, right? 256 or something. Yeah, I think 256 integer, yeah. So, okay. Okay, Maxim, any more questions?
No.
Okay. So in terms of operations on schemas, which schemas are likely to have operations?
Voting on the expanded request.
Okay, vote.
Vote.
Okay, vote. Okay, which schema will have this?
Expanded request.
But like, who calls vote? Shareholder, right? So he has to go to expenditure request to vote.
Because if you vote, you will show the expenditure.
Sorry.
Shareholders will make votes for the expenditure request.
Okay, one question. I mean, it can be, but will your expenditure request be a separate contract?
If it oversees the limit, it may go to the other.
Okay, but like, it will not be a separate contract, right?
You should just have another bullet line that here need to vote on it. Just a flag which checks under this condition.
Maybe we have different idea in mind, but like we have only one contract here, right? What is the contract that stakeholders do with shareholders? Fund. Requests are just things inside fund, right? That you create. So as a stakeholder or shareholder, you only directly call upon functions from what? From the fund, actually. You could declare it differently. I mean, you could declare it the expenditure request, but like if we're talking about, again, smart contracts, it's going to be a contract inside the struct. So we don't need methods for extension requests. We only need methods for funds. Vote is a method on fund. What else? What other things?
Request expenditure request. Or how can we say it? Make expenditure.
Okay, yeah, or create, yeah, something like this. Make expenditure request. Okay.
For example, withdraw operation. No.
Withdraw. Who will withdraw from and from where to what?
From my fund. No.
I mean, withdraw would be an operation in property contracts, I think, like in property, because you're the owner and you want to get your money. But inside medical fund, there is no withdrawal, right? There is only, you create an expenditure request. If it gets approved or if it's below the limit, it gets transferred to the recipient. So I don't think you need withdraw as a function here. Any other suggestions? Sorry? Okay. So deposit, you mean? I no, but withdraw is the opposite of deposit, right? So okay, deposit, contribute, or like contribute. This is basically you want to contribute to do what? Why do you want to contribute? Yeah, to become a shareholder, right? So you contribute, become a shareholder. You can create expenditure requests. You can vote on expenditure requests. That's it. I mean, like this is enough. You can also make a separate complete function for expenditure requests that have been approved. But alternatively, we can just at vote, if we have an efficient mechanism of checking the vote proportion, we can check votes at after each vote and transfer once we are above the threshold. Okay, good. Okay, so now let's talk about medical fund. First of all, we have the schema, right? We have the schema. I think now we will switch to the board to follow the Z notation.
Excuse me. Relevant sets should be always a simple object.
Sorry?
Relevant sets should be always a simple object. In our example as address.
Yeah, it should be always something simple, yeah. Because anything else, anything that is not trivially, that does not trivially map to a simple type, you have to declare a schema for it. Do you understand?
Yes.
Okay. Okay, so let's. Maxim, can you see the board?
Yeah, it's okay.
Okay, good. So here we are having fund. This is our schema for it, right? Okay, schema for fund. What are the variables we have? What are the properties inside?
Maybe the choice.
Maxim, do you see it properly or it's inverted for you?
It's okay.
Yeah, okay.
I think limit.
Okay, definitely. Like for this, I think we don't even need this. We need the requirements, right? Because this is each fund has a limit. Limit is what?
Minimum sum that you can contribute.
It's a minimum sum. You mean limit for joining, right?
Yeah.
Okay. Do you mean limit for joining?
No.
You mean another limit, right?
Yeah, it's for sharing all like the
Yes.
request.
So basically, if you didn't reach your limit, your requests go automatically, right? So we have two types of limits. We have minimum contribution, and we have limit like on expenditure, like expenditure limit somehow. Okay, expenditure limit. Okay, good. So what are the types for that? Real numbers. Okay.
Well, for Ethereum, I think it's not relevant, but real numbers.
I'm not sure. Can you declare reals? I never dealt with reals yet, so okay. I mean, it doesn't matter. We could make it real. We could also make it natural number, right? What definition of natural numbers do we use? Do we include zero or not?
Yes.
Okay, it's a choice, right? But you have to make this implicit or explicit. One thing that I want to pay your attention to, which is super important. Whenever you declare a schema or initialization on operation, you always have to substitute it, supplement it with natural language commentary. So you provide formal notation supplemented with natural language commentary so that your together there is no doubt what exactly you meant. Okay. So okay. So okay. So natural including the zero. What else is there? What else is there in the fund? Set of contributors, right? Okay, so like basically shareholders, right? Shareholders. What will be the type for them?
Address.
Address. Okay. So shareholders, this is not one address, right? It's a bunch of them, right? So it's a set. So the way when we want to say that it's a set, we use this notation. It's a for power set.
Maybe it will be struct.
We can do it, but then it means we'll have to introduce an extra schema called shareholder. For simplicity, we're not defining a separate schema, but we're making the most basic things that can help us identify the shareholder which address. But Maxim, it is possible, yes. It's just not the choice we are making. Okay,
because often address is address of the wallet. It's not address of the maybe. It's not a string. I mean,
it's not a string. Yeah, sure.
In our case, maybe shareholders. It's maybe with names or etc. attributes. No.
We could, but strictly speaking, in Ethereum, the only thing you care about is the address. For example, if I'm owning the account, if somebody steals it from me, I cannot claim it that this was my account. You know? It's like basically that's it. Whoever has the account has the identity in blockchain. You know? This is the simplest thing. But like, if you want to go deeper and attach that, okay, you have name and so on and so forth, but I would keep name in a separate folder. Because what is Ethereum? If you have access to your account, you should be the only one having access to your account. You shouldn't share your password with no one and so on and so forth. Whoever has access to your account, that's it. You know, he can use your funds, your everything. You know? So address is it works. You can go more complex than it, but like why? Okay.
Okay.
One thing that I want to pay your attention to this P, it means that it's not one address, but a number of things. It's a set of addresses, right? So here, if we want to say that it's a set of natural numbers, we would also put this power set sign in front of it. This is the notation of Z, okay? What else? Shareholders, okay? What else do you want to keep track of? Okay. Requests. Okay. Requests. Okay, what is the type for it?
Also addresses.
No. It could be addresses, but like we have for requests we have a type, right? It could be addresses as a map if you want to map shareholders to their requests, but again, why? Boolean. No, not Boolean. Sorry.
It's like another scheme.
Yes, it's exactly another schema. So this is the beauty of Z and programming. When you declare a schema or a class, you can use it as a type in other classes, right? Expenditure request. Is it one expenditure request? No, it's a set of them, right? So yeah. So we already have a shape in our fund, right? Okay. What else is there? Requests. Okay. What else?
We should know how many money we have.
How much money we have? Okay. So there is some sort of balance, right? Which is probably again natural number, right? Okay. What else? That's it. Okay. How do we keep?
Maybe percentage of votes, because shareholders need to vote to do this request or not.
Okay.
Percentage of votes, maybe. No, amount of votes.
For sure, we need to keep count of votes for each expenditure request. Since the vote, we need to keep it for each expenditure request. It makes sense to keep track of votes inside the expenditure request, for which we will have a separate schema. So let's declare the schema here. Expenditure request. Maxim, do you see the two boards?
Yes.
Okay.
Always
so
great.
Request. We said that we'll have some sort of votes, right? And what will be the votes? So it's for sure it's not something one. It's a set of things. Set of what?
Addresses.
Which addresses? Okay. set of addresses who voted. Okay, makes sense. So we keep only positive, right? Like for negative, we don't care because we only care who voted yes. Actually, if you want to, there is no reason even for you to vote no. Why spend gas and vote no? Because it basically, if you don't agree, don't vote, you know? So you're not contributing to the percentage moving beyond 50%. Okay, so I remember like in your implementation, sometimes you would give opportunity to get to vote yes or no, you know, but like you don't need to, right?
It has some reason.
Yeah.
If you want to preserve funds on the balance of this fund.
Yeah.
So why, if I think that this guy just tried to cheating somehow, and I know, I just want to decrease votes, this negative my.
But the thing is that not voting and voting no is the same because there is number of shareholders, right?
It's like a decrease number of all votes that count. It decrease counter of full votes. So if you have 5 vote for and 2 vote again. Yeah. So it's like 3.
It gets approved. If you have 3 shareholders, 2 of them voted yes and 1 no, it's beyond 50%, right?
I mean, if you just count presence, okay. But if you do it more complex, I mean, if you vote against, it's like decrease total number.
Okay.
Not just, it's like I'm not. It's like I'm not vote and I vote against. It's different things because when I not vote, I'm just not decrease total votes. But when I vote against, it's like decreasing.
I don't think so. Because it depends on how you calculate, but here it says a half of all shareholders. So basically you need more than half of all shareholders, not only half of all shareholders who voted. If you say everybody who voted, at least 50% of them have to say yes. Then your logic works. But if it's 50% of shareholders, of all shareholders have to vote yes, then no voting and voting no is the same. Okay, so it's addresses. Also, since we need an efficient mechanism to count the number of votes in favor. Therefore, my suggestion is to have vote count. Well, we can obviously always say that give me the count of this set, right? But a more efficient implementation within the smart contracts is to whenever you add anything to here, increment this one, so you don't have to calculate more and spend more gas. So this is one thing, but it's not a must. It's more specific to smart contracts to make it more efficient. Okay, what else do you want in expenditure request?
Some voucher. No, for owner this request.
Okay, owner. Okay, so basically
Request.
like requester, requester. Okay, requester, and this will be what? Address, address. Okay, good. So you have requester, you have vote count, you have votes. Okay, what else? Sum of what? Amount, So basically, like how much you want to be transferred, right? So again, this is probably some natural number. What else? Completion, right? So basically status or completion. Okay, completion. What will it be? Boolean. Yes. So something we've declared that has only 2 values, right? Okay. What else? If it gets approved, who gets the money? Requester. Okay. Alternatively, we could say the recipient, because sometimes when you are making a request to be spent, you might specify the recipient, and the smart contract will transfer to that recipient. It can be relevant because when I'm creating a request, I'm saying I want to spend it like on doctor, right? If the smart contract will transfer the money to the doctor, which I specified, it's more secure than it's giving me the money and then I have to spend it my own way. You know? So this way you can specify recipient. Not a must, doesn't matter. I mean, like for our purposes of this specification, not a big deal. Okay, what else? Anything else?
By the way, do we somehow freeze money when we make expenditure request?
Do we freeze money when we make expenditure request?
Oh yeah.
No. No.
Okay. What if we had some more expenditure requests amount than we had on our account?
Then the thing will not go through. So basically, I mean, it's for us to decide. We could freeze the money, but the thing is that it means that for expenditure request to get through, there are two conditions. One condition specified here, the other one, which is implicit, that there has to be enough money in that. That amount should not be greater than the balance.
We can have two requests simultaneously.
One of them will go first, the other one will fail. This is for Ethereum to handle.
In this case, it has some reason to vote against, to somehow do it faster, to make our request.
But when you vote no, for example, what will happen? Which one do you want to make faster? The one that you're voting on, the other one?
That's for which I vote against. So it's like more votes, but again, it's like it depends how we vote.
Yeah, I think this is a valid point. So imagine everybody voted. So if our completion mechanism transfer checks after each vote, right? Imagine we voted and it got approved by the number, but didn't go through with the money. Then we have enough money, but nobody votes afterwards. Just like the new guy who joined, he doesn't want to vote, but this already got full approval count, right? So there should be a mechanism to say, okay, complete it, you know, if it can, so to check completion even without voting, right? So maybe completion should be a separate function, but we have to think about it. Part of this doing the specification is the reason to think about these things in advance. That's the whole point, for you to reason how it's going to work, for you to reason what's going to be the dead ends. Because if the worst things that can happen to smart contract, like apart from money being stolen and it's broken and so on and so forth, is when you enter a dead end. So the money stays there, you cannot do anything. And such situations happen actually, when when you don't consider all the scenarios. Okay.
Some interesting things. When we got $1,000 on our account.
Mm-hmm.
Someone wants let it be 800.
Yes.
And some expenditure request for 800, and no one wants to vote for it. So if we freeze this money,
yeah,
it's like freeze for a
yeah.
while.
Yeah, that's why freeze. I don't like this idea of freezing.
But in case if we do not freeze, it's like we will have a lot of expenditure requests that's approved.
Yes.
But we can found them. We can't give that money.
Yeah. For me, this is preferable, like my personal opinion, rather than freezing. First of all, freezing money adds complexity. You need some freezing mechanisms first. Maybe it's not that hard. You just need to calculate the amount and not create new requests. But for example, what if the money is frozen? As you said, it's a blocker for new requests being created. Mm-hmm. So for me, I would prefer first come, first serve. No money, nothing. What can I do, guys? You know?
So we will just waiting for enough balance of our account to give them to some.
Yeah, we need economy of scale. We need a lot of people, And the idea here is the same with the insurance, right? That most people won't claim it. That most people, I mean, thank God I didn't go to doctor. I don't know, since I got here, I never went to doctor, you know, unless like for out of my own desire, you know, like because I was sick or whatever, you know? Because I normally don't go to doctor anymore. But like, so I'm a perfect client for insurance, right? Okay, so that's the assumption, such assumption is there, but like we need to unlock what is called avoid deadlocks. Okay, balance. So balance is n request. We've declared that there is expenditure request, and we kind of know what variables it has. It's not finalized yet, but okay. How do we track the limit of each guy? So each guy will have a limit, right? For example, I created an expansion request below the limit, it got paid. This we should keep track of my spendings, right? Because what if I create a lot of requests below the limit and then spend the whole money? You know? So we should keep track. It should accumulate, right? My expenditure. How do we keep track of it?
We should have like some set, some relation.
Yes.
Account and some.
Yeah. Actually, particular type of relation we'll have is function, which is like maps account to how much I've spent, right? So here we will have, let's call it spendings, right? Spendings. And what it will, from what to what it will lead.
From shareholder to integer number.
Okay, so it's from shareholder, which is address, to natural number. Is it a total function or partial? What does total mean in terms of discrete mathematics?
Every element has his relation.
Yes, so every element in the set on the left has something on the right, right?
Yes.
Do we care about the whole set of addresses in the theory?
No, there are cases when someone contribute and have any.
No, we care obviously about all these addresses who are shareholders, right? But we don't care about the whole set of addresses because shareholders is only subset of that set, right? So it's a partial function. How do we show partial function? I think like this, right? Yeah, partial function. This here, like first, I understand your logic. It should be total because every shareholder should have at least 0 there, right? But address is not shareholders. It's a set of all addresses, right, out there. So here you need to understand discrete mathematics to abstract from this particular, but it's still mathematical notation. So we have to obey by the law of mathematical notation. Okay, anything else? For me, I don't see anything, to be honest, but we might be missing something. Vote whether to approve such a request. Any request gets approved more than half of shareholders proceeds to completion, funds get transferred to the recipient. I think we took care of everything somehow. Maybe something else will come up. Now, fun part is to think about the, what here? Invariance, right? Invariance that we declared. What could be the invariance here?
Maybe balance always positive.
Balance always positive. Can it be 0? Okay, so it's not always positive. It's
Positive or not negative?
not negative. We don't need such invariant. Why?
It is invariant of mathematics.
It's because
No,
natural
not
number.
even. Yeah, natural number already cannot be. So this is invariant, but it's given already in our notation. Same applies for expenditure limit for minimum contribution. But do we want them to be 0?
No.
We don't, right? It doesn't make sense. I mean, like maybe minimum contribution won't anybody, but 0 again, too much. Like contribute 0. What does it mean? You know, it's no contribution. So it makes sense to say that the expenditure limit should be above 0 and minimum contribution. Minimum contribution. One thing that I want you to think about is the initializer, initialize fund, right? And this is like a function. So here you have to say which schema it relates to. Fund, okay. So fund. I think initializer you don't need to put any things. Like so, you're basically saying that this is fund and it's been initialized. Bless you. So here, what will be the input parameters?
Limits.
Okay, so let's say limit. Limit is an input parameter of type natural number. Okay, and
I think we should have two limits.
what two limits?
I mean, minimum contribution.
Okay, and minimum mean contour. Okay, so again, pay attention to something. These are input parameters. I even given them different names, right? So these are the two things we'll pass, nothing else, right? The rest, and we will not output anything as initializer. Initializer, like it's basically there's no output. Here you write what happens. So like it's not post condition, precondition here. Rather, it is. You can write preconditions actually initializer, but the main point of initializer is to initialize all of them, right? All of them should have some default value at the start, right? So,
but by precondition, post condition, you mean for input variables, right?
For input variables, yes, mostly for input variables, but it depends. I mean, like precondition, post conditions can involve schema variables, but normally in initializer fund, no. So what will be the thing here? The point why I switched from fund to this one, that you can introduce this also as the initializer. Doesn't matter. Because invariant, it should apply it everywhere, right? So it will cover this one. And maybe this is more robust. Because here you are prohibiting to change it later to negative value. If you only have it here, you ensure it at the start, and as long as there is no method to change it afterwards, you're okay. But method could be introduced afterwards, right? To change that, to change the minimum contribution, to change the limit, makes perfect sense. So here it's more robust. Okay, if it's here, you don't have to cover it here, right? So it's enough to cover them, as this covers already all the operations and everything. These things will never be negative, or will never be, always will be positive. Otherwise, you break it. Okay, so what happens here?
We should assign.
Yes, so basically, first of all, expenditure limit. You assign to what? To limit, yeah. To this limit that we passed. Same with minimum contribution, and here min cont. Sorry guys for first for my writing, but also anyway, minimum contribution. How do we initialize these things? Shareholders at the initial, what should it be?
Empty set.
Okay, so shareholders is empty. Empty set. Requests. Requests. Okay, empty set. Request, in fact, yeah, okay, it's a set. So empty sets. There are no expenditure requests for sure. Balance. Balance 0. Balance 0. And spendings. Empty set. Some would argue that this is function, but any function can be represented as a set, right? It's like just pairs from input to output. So it's fine. Like you can define functions in terms of set series. Therefore, you can initialize it as empty set.
Unless it's represented like set and two variables in each element of set.
Okay. 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 But the beauty of that anything you can do with set theory that is valid in set theory and discrete mathematics is valid in Z, right? Because it's mathematical notation we are saying. So if this is valid, this is valid in Z. You cannot argue with it. Okay. This is our initializer function. Okay, let's continue with, now we have more interesting invariants. What invariants can you think of? What invariants can you think of here? You want to make it help you make a more robust implementation, right? And safeguard you against some things. What can you think of?
Spendings amount, shareholders amount.
Spendings amount equals to shareholders amount. So basically, we want, you mean amount of these elements, right? Okay. What is the elegant way to specify it? The most elegant way to specify it? The main of spendings. Amazing. The main of spendings should be what? Should be equal to what? To shareholders, definitely. You don't care about spendings of others, right? You want the domain of this function. Domain is as the elements here. This is range. Okay. All the things that we see is the keys. The keys. It's a map, right? You can think about it as a map. The keys as a domain. This is the range. Okay, the values as a range. So with domain of these spendings, we want to be equal to shareholders. What else?
I'm sorry, is it domain should be function?
Sorry?
Domain is the function, as I remember, with the parentheses.
Okay.
Or is it is
No, I don't think so. Basically, what you do in Z, you would, if I remember correctly, we can check it, yeah. But maybe we can check it as a lecture right now. Let's check it. For sure, somewhere domain should have been used. Where? Ah, okay, you're right. Sorry, wait. Standing for, no, I mean like, let me, somehow it seems to me that I've seen domain somewhere today. In this is the thing that I told you about. Okay, domain. What Manuel was using inside the thing is normal mathematical notation. Like I wouldn't be against it if you used it, but here you see like he's not using it. Okay. 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 Same probably applies in terms of domain. Same applies for requests, and here it's even more relevant. You don't want to have requests from anybody except your shareholders, right? So requests should be. But in requests, what exactly do you care about? Because you cannot say request equals to shareholders, two different types, right? What do we have in requests?
Maybe we should have this invariant in the schema to the expenditure request.
We could, but here we don't have expenditure request doesn't know about the fund, right? It's funds that knows about expenditure request. So it's better to like introduce it here.
Well, you mean we should get the requester?
Yes. Yes. So look, guys, here you're gonna use like you can use set builder notation. So shareholders should be equal to what?
Maybe or
should be superset, right? Superset of, I agree, should be superset of what?
well, I don't know how to express it, but all requester
Or requesters from. So guys, what we do here, we're gonna use set builder notation. We can use set builder notation the way we want. We're gonna say give us all elements. Here we declare element. Let's say for example R. All R's that satisfy, and here you say the condition that satisfies this condition. It is very common to use, for example, in functional programming. Set builder notation, but this is discrete mathematics. Maybe we were using this in Prolog as well. So we're saying, give us all requesters that satisfies the following thing. That okay. Okay, tell me how to do it.
We need to somehow get requested from this. How we should do it.
Okay, here let's one way we can do it. We have predicate logic, right? So we will say that okay, for all requests from requests, right? Then we can say requester requester equals or actually R equals requester, but it doesn't matter. It doesn't matter. Do you understand this? So here we are saying that requests. So see here we're saying for all requests from requests, right? And then we're saying that this request has requester, right? And we're saying that this R should be equal to this to this request. Requestor. I think I'm doing it correctly.
Oh yeah, you're assigning to R.
Yeah, I'm saying that if this R equals, or no, let's do it not for all. Let's do it. Maybe do it there exists. There exists. No, I think the problem here is that let's say that for all, yeah, I think let's correct it a little bit. We'll say for all, let's say address from addresses. Okay. For all addresses, then we will say for all R from requests, R address equals to R requester. This doesn't feel right to me, to be honest. I don't like it. So what I'm saying here, I'm saying it's a condition, right? That I'm saying. That I'm saying for all addresses, an address.
Not look like addresses, right? Share folders. We should. Like all requests.
Yeah.
Requester is in the stakeholders.
For all requests, requester is the stakeholder set.
Requester is in stakeholders.
Yes, much amazing, much simpler. Like I'm overcomplicating it. What Daniel is suggesting is much better. So what Daniel just said, for all requests in requests, you're following, right? For all requests and requests, so far very clear. What should be true? It should be true so that requester should belong to shareholders. That's it. For all requests, the requester should be from this set of shareholders. Very simple, very nice. Thank you. Okay. This is more interesting and less trivial. You know, they just say even above zero. But sometimes even such trivial condition might be useful. You know, might reveal a bug, as Bertrand was saying, right? So spendings, request, we specify the spendings, we specify the requests. I think we tied it to shareholders. Good enough in terms of invariance for our fund. Let's specify maybe one or two operations and then break. And then we'll see what to do in the second part. Okay, Maxim, are you with us?
Yep, now yes.
Very good. Very good. So for expenditure requests, what should be the invariance? What should be requests invariance for expenditure requests?
Can we use shareholders
in here?
Yes.
We could refer, but like it means that here we have to have some reference to the fund, which doesn't make sense, you know. You remember in GRASP, who should be the expert, you know, the one who should know about who. So in this case, it makes sense that the fund should know about expenditure requests. Expenditure requests should know about the fund. You know? Yeah. Some things. Okay. Can we do anything on votes? Actually, here we can specify that the votes should be also only from the stakeholders, right? Shareholders. Yeah. We can specify it here. Good. Everybody understands, right? Similar to this logic. Okay. Then okay. The only difference that we would say for all requests for all requests in requests, request.votes should be what? Subset, because votes is a set itself, right? Yeah. So it's not element, but a subset of shareholders. Mm-hmm. Okay, good. Vote count, what should it be?
Non-negative.
Sorry?
Non-negative.
Non-negative, okay. Non-negative, natural numbers already excludes negative. We can introduce here also an invariant. What invariant? So vote count, how many counts can you have?
0.
Yes, so basically it should be below or equal the length of shareholders, okay? The count of shareholders. Count in Z, you say like this, okay? Count shareholders. Okay, so the votes for all requests, the vote count should not exceed. Ideally, what I would do, in the same logic I'm here introducing vote count, instead of using count of shareholders, I would introduce a variable called shareholders count and increment it every time a shareholder joins to access it directly and not repeat the calculation. Okay, requester, in terms of address, we already specified something on it, right? In terms of amount, what should be the amount? Natural number, it cannot be 0, right? Doesn't make sense. So So amount should be above 0. Okay. What else?
Not only on 0, but also about limit.
But we haven't this limit in expenditure request.
Okay.
So we
Above limit. Why? What if I create an expansion request below limit? What happens? What happens to such a request?
Money transfers.
Automatically, right? Should we keep track of such expansion requests? Or like we still create it, right, as an expansion request? Or not? Yeah, depends. Depends.
We can just add it to spending, but not have the expenditure request.
Yeah, we could. It depends on how we will specify create request, right? Make request. Okay. So amount could be above limit if we do the logic that we just discussed in the make request. Okay. Completion in terms of like what should be completion? Any invariants related to completion?
If count is less than 50%, then completion can be.
Yeah, we don't know how many groups, how many contributors are.
Yeah.
So again, we should add this in pound.
I think like here we will not specify because sometimes we don't know the moment when it was completed, what was the number of contributors, right? For example, now we have 4, 3 voted, we approved. Tomorrow another 5 joined, but this is already completed.
Yeah.
So like, yeah. Okay, I think generally speaking, like this is amount, and we could say that amount should be below balance. But again, like it's not does not work in all cases, you know, because it's an invariant, right? It's an invariant. So some expansion request was approved, and the current balance went below my existing expansion request. So okay, good. In terms of initialization, very quickly, votes. How do we initialize it? Okay. First of all, what are the input variables? What is it? Amount. Okay. Amount requester.
Yes.
Amount and requester. Yes, I think this is it. So okay. So I would actually specify it here, to be honest, because I will tell you why. No, okay, initializers, that's it. So amount and requester, we are passing to it. Then we are saying that votes will be what? Empty. Requester, we know. Vote count will be 0. Amount we know. Amount will assign it the input variable. Completion, false. Okay.
But we should check that requester is who invoke this function. We somehow should specify that, but I don't know how we can do it in that.
Yes, this is true. We will have sender.
Yes.
Sender input variable. You understand? Because
so,
in Ethereum it is an input variable, just implicit.
Oh yeah. So it will be a third input variable, right?
Yes. Yes.
Oh, okay.
So basically, it will be input variable instead of requester. It will be the sender, and we will attach requester to the sender. So it will be still 2, but yeah. That's it, guys. Let's specify one of the functions. Which function should we specify? Which function do you want to specify? So we have what operations? We have vote, make, expenditure request, contribute. Okay, contribute. Where should I write? So contribute. Okay.
Maybe expenditure request.
Sorry.
It will be expenditure request.
Make expenditure request.
Yeah. It's more interesting now.
Okay. For me, the most interesting is vote, to be honest. But like, let's try to make it. Make expenditure request. Okay. So make expenditure request. Okay. Make expenditure request. So what should be the yeah? What should be the input variables here? What will be the input variable? Mount. So, in fact, let me think about it. Like the thing here is that in Z you don't have a way to invoke function here and here or operation, and I mean here is the initializer, right? Initializer. Yeah. So you will have as input here expenditure request, and here you will make of type expenditure request. Which means that you assume, like basically for input variables for the initializer, for this one, you assume that it already been initialized and passed to you, okay? And then you will have to go and refer to the, which we didn't specify, to the initialize function of expenditure request, okay? Do you get it? So here, look, we will have initialize expenditure request, right? Expenditure request, which we talked will have sender, which is address, right? And it will have what else? Amount. Yeah, as natural number. And here we will then initialize all the properties and so on and so forth. At the end, we'll have initialized expenditure requests, right? In our code, what will happen? This function will receive these variables, initialize it inside, right? But in Z, we're not gonna mention them here. They're implicit. We're saying that there is expenditure request being passed to us, okay? And we assume that it has been initialized here. So if you want to check what will be the things that will be passed here, you have to go to that one, okay? It's kind of, I mean, I think it's a drawback. Maybe there is a way to specify it, but I haven't found it. So this is a convention we agreed on last year with students that we send as if we assume that it has been initialized at this point. And all the things, all the variables will just say it's expansion request dot. So we can still specify some things that we are conditions, post conditions, and so on and so forth. Okay. Okay. What happens next? Makes expenditure request. So you pass the expenditure request. What happens? Here we're gonna start. Very important. What thing are we working with, right? Even before declaring this, we have to declare what schema we're working with. Fund. Are we gonna change it or read only?
Change it.
For sure, change it. Okay. So and here we will say expenditure request. Since so we will call it like this, not to write the whole thing again. Expenditure request. It's a variable. I'm the one naming it, right? Okay. Expenditure request. What happens here? So now we're saying that we're changing fund, right? We need some preconditions. What should be the preconditions for it and post conditions?
More than amount.
Balance more than amount. We could. So you cannot make a request that is greater than the current balance. Okay.
Because we agreed that we will check it after.
Yeah, I mean, I wouldn't put this limitation here. It depends again on us. But what if I want to make an expenditure request for people who will join afterwards? It's a discussion point. Like, should we do that or not? Yeah. So, yeah. Okay. For now, let's say that amount. So this is like question mark still, right? Amount should be less or equal to balance. Okay. All the variables from the fund, we don't have to say fund dot, we access it directly. Okay, should be less than balance. Okay. What else?
And the requester shouldn't be on the list of requests.
Requester shouldn't be on the list of requests.
Only one request for a person.
Expenditure request. Why?
We will have implementation for it, but we can maybe need somehow to calculate spending on this.
We are calculating spendings, right?
Yeah.
We are keeping track of spending. So we know for sure that nothing will go without our approval above limit. So I don't think that we should make this limitation. But I mean, keep it simple. For example, obviously simple does not always mean correct. Sometimes keeping it too simple, you miss things. But here, when request is completed, do we delete it from here, from requests?
No.
No. So it means that there can be more than one. Okay. Expansion is less than balance. What else?
Can this be fun?
Sorry?
Fun schema. Maybe
Okay, fund schema here. So what do we have?
Should we check for limits? I mean, this is more than
More than?
this. So maybe some situation when this amount will be less than this. It's like prevention.
Okay.
Precondition that it shouldn't be so, but I think it's good to have this.
So you are saying that if it's below limit,
We shouldn't make such a maybe in it maybe not. I mean, in the state of initialization, we should maybe the condition maybe not true.
I mean, one thing we could do, and it makes mention is that if it's below limit, expenditure limit, right? No, here we have the spendings, right? We can check that if the spendings of this guy plus the amount he's asking for is below the expenditure limit, the request should go through directly, right? We could do it here, yes. We could.
Yeah, but by the way, we have only operation with make expenditure request. Does it mean that it's only to create request? So it's like more than so. We should have operation that's just give money to him directly.
I think let's specify it here. So, and it will be also interesting in terms of this is a post condition. That's what should happen, right? So look, how can we do it? We have expenditure request. Who are we transferring money to? To requester, right? To requester. So expenditure request. Requester. Okay. expenditure request requester. In what case do we want to transfer the money directly?
Amount less than expenditure limit and no. Sum spending plus amount less than expenditure.
So let's make it and finish up with it, because I think this is interesting enough for us to look at. So first of all, we want to check if it's more or less than if he exceeded limit with this request or not, right? So we are saying that first of all, there is spendings, right? Spendings, and it's a function, right? So we can pass to it expenditure request sender. Even though, or like requester, right? Requester. Even though we should have sender here as well as an input parameter, but for the sake of like continuing, let's continue. If this thing, and it will give us some amount, right? Plus what? Plus expenditure request amount is less or equal, maybe, yeah? Less or equal than expenditure limit.
Should we remember fund though?
No. We already connected like Joe was.
Oh, okay.
So guys, look, this is one possible scenario, right? This could be a case, right? Then we're saying that and expenditure request again requester I will put this dash saying that it's a post condition. Okay, dot requester, and we should have a way, I mean, like, we assume that from address we can get balance, you know.
Yeah.
Here it's like a shortcut I'm doing, but like there should be a way that from address we can get balance. In Ethereum it is a function, right? You can say this address dot balance. Balance equal to what?
Amount.
I would actually even make it like this, putting this one here. Equals expenditure request at the requester dot balance plus amount.
Sorry, so we assume that address is another schema, right?
No, we are just making a shortcut that we can go to balance of address.
Just
okay.
Our agreement. Right?
Yeah, I mean we have natural language commentary, right? So we can provide that in Ethereum you can directly from address you can directly take balance. Maybe in this case it would also make sense to introduce a schema account where you have address and balance.
Yeah.
And then it will be more sound. But here, what I want to pay your attention to. So we are saying that this is one scenario. Either this is true and this is true, that in the post condition of expenditure request, requester balance should be expenditure request, requester balance plus amount. So his balance at the precondition plus amount. You understand? Which is a risky thing to do in Ethereum. Maybe like it should be, maybe he spends something in between, you know. So I would say, or another sum came to him with the same transaction, with the same block. So I would safer to say that more than equal, greater or equal to. In fact, if I was specifying, I wouldn't specify this in Ethereum and solve it in the smart contract at all, because it's very hard to say what should be the balance at the end. But check this as a like the main point I want to demonstrate for you is that conditional post condition. This is one scenario. What if this is false? Then this whole thing cannot be true, right? If this is false, this we don't care. I mean, like there has to be something else true, right? Because we have to satisfy it. And we're saying, or we will produce the opposite of this. And what? Then this we don't care about, the balance of this guy, what we care about.
Check if in fact his request is with, right?
Yes. So either it is he's below expenditure limit and we transfer the money, or he's above expenditure limit and we add the expenditure request to the requests thing. Okay, so expenditure request should belong to the requests at post condition. You understand? So either this or that. Not as intuitive as if else, but the same thing. So we are saying either this or that. No third option. One of them has to be specified. And this is one big post condition. That's it, guys. That's great. Let's go for a break. Maybe what I will show you, like in the second part, we will have a look at more operations because we only have a very brief look at one operation. I will show you examples of operations, and then let's go into the event-based system. Yeah, I think we should have somehow enough time. Okay, guys?
What time for the break? What time the break ends?
At 3:50. Actually, we're not gonna do the event-based system. Let's finish with that. So we will have 18 minutes break now. I think we all need a good break. So we'll come back at 14:50, and for 1 hour we will look at more operations. And the event-based system will do next lab to have more time. Okay. Pause share and pause. Okay. So let's see. What do we have? What do we have? Okay, this is the midterm. Okay. See, just a second. So guys, look, here's like, it's one of the teams that was doing it last year. For them, it was the final exam. And the specification was a little bit different. Instead of medical funds, they were doing crowdfunding, okay? But the overall idea is similar. So you know Kickstarter. In Kickstarter, you can create a campaign and make people donate, right? And then you make expenditure requests. The idea of smart contract is that all these donors who contribute money to a campaign, you can then create expenditure requests for them to approve. Whereas in Kickstarter, they give you money, you spend it as you want, right? So here is like extra control for the donors. So that's what they did. What I didn't like was this function. I was confused with the like reference to expenditure request, and like can we say that since this is just a local parameter, right, that we're passing, And then we're saying in post condition that referring to it which normally we only use for the schema variables. Normally we would use this post condition sign only for schema variables. I wasn't too comfortable. So this I think is better design. So they're saying in initialize expenditure request, they're saying, okay, this is expenditure request. This is for what we're initializing. And then saying we're going to read campaign. So they're accessing the campaign in which it is a context for this initialization. Okay. And then you have the purpose, amount, recipient, sender. Okay. So in their case, recipient and the sender are different people, not in our case, right? In our case, sender. So we don't care about purpose and recipient. We care about on the amount and sender. Then they're saying that, for example, here a manager is manager of campaign. We don't care again. Okay. So recipient doesn't belong to supporters. These are some of the preconditions they're specifying, right? So that only manager can create this expenditure request. In our case, what we would care about? That sender is from what? In our case, yes. So we would say that the sender belongs to stakeholders, right? Stakeholders. So you understand it, okay? Okay. Then we would also say I think this makes sense. Amount should be above 0 and below balance minus some. This is what they're saying. In our case, it's only above the amount. And then we are assigning all the things that we want to do. So here, what we were trying to specify, in other words, if we assess the fund here, we can already refer to stakeholders and so on and so forth. It will be easier to introduce these preconditions here. Then what happens? One thing I also want to pay attention to. So we've initialized all the variables for the expenditure request, right? And then we're calling on add expenditure request. We're saying that it will change the fund. There is request and there is sender being transferred to it as input variables. Okay, so they are adding requests at post condition should be request at precondition plus this new request. So they are adding it directly, right? Because they don't have that. If it's below limit, then it goes through directly. If it's above limit, it doesn't go. For them, any request has to be approved. So they're adding it directly here, okay? And changing the campaign. Then what else they're doing here, which is also relevant to us. Okay, then they are, look, manager and post condition the same as manager. Precondition minimum amount as a post condition same as the minimum amount as the precondition. Supporters, that's the specifics of that. You have to specify that since you're saying that you're changing campaign, you have to say what happens to all variables, all schema variables. Even if they don't change, you have to explicitly say they don't change. Okay, this is specific of that. All, if you're saying that you're changing something, you have to say what happens to all variables. It doesn't go that if you didn't mention, then like everything has to be explicit. And for the complete request, they're doing number of approved supporters, so on and so forth. I think like they don't have conditions here, right? No, they don't. Yeah, so conditions are demonstrated to you here. How to do it, for example, conditionals, how to do it with that. That you say either this or that. And here you specify the like what should be the post condition in this scenario, or what should be the post condition in the other scenario. I think that's it, guys. More or less, like we somehow covered that.
Is it possible to pass this document to us as an example?
I mean, it's student work, so it's not perfect, right? It's far from perfect. I could come up with something similar, right? So for example, I will give you an assignment on Z, right? Where you will have to specify, you need some, something to copy from, right? To take inspiration from. Okay, I will update this or some other work and share it with you. It's fine. Maybe some simple examples. Okay.
May I ask?
Yes.
You said that you will publish the additional tasks.
Yeah. I mean, I didn't say when. So, like, I will have to prepare them. I'll have to prepare them.
We already know it's a bit to come.
Yeah.
The 27, 29 of April. That's why.
Sorry.
27, 29 of April are a bit of an exam. That's why I asked.
Yeah. So the thing is how it will go. I will probably release it before that, but we need to finalize the course by the time, Manuel made the retake, right? Already in May. You know that there is like oral exam, and then in 2 weeks there is retake, And I think he's not planning to make it official retake, but like it's like a two times trial or something like this. That's his idea. So probably in this gap between after the final oral exam and the retake, you will also have time to work on assignments. I'll think about it. I haven't thought it through.
So we can't do additional tasks because
you can get it. I just don't want to promise things that I'm not sure I will deliver, because yeah, at the moment I can't say anything that when you will get them, but you will have time to work on them for sure. So don't worry about it. I mean, do remind me. Thank you for reminding, and this will probably make me produce them faster. But I will make sure that the conditions are viable in terms of time for you. Okay, this is the main point. Any more questions? Any more questions? Okay.
I have a question about course assignment.
Yeah.
In second, one of the warning is like there aren't any acceptance or something. What is acceptance?
Let's look at code test, right? Let's look at the code test. Honestly speaking, I don't remember, but let's see. Okay, say validator.
W1.
Which one?
Well. W1. Warnings, W1.
W1 accepting state is not defined.
What is accept?
It's initial state, no? You have initial state here. Accepting state. Which one? Like you mean final states. From the initial state, FSA is not deterministic. Yeah, maybe. Because it makes sense to have a warning about it, right? That the final state is not defined, because there can be machines without final state.
But it should be maybe an error because it is not.
No, it is. Finite means it's finite number of states. Yeah. As opposed to infinite number of states.
We have example. We have W1 result. Yeah. But it's slightly confusing acceptance state.
Acceptance state is not defined. Yeah, I guess it's a final state, right? Because what else is not there? I mean, transitions are involved all the states. There is no final state, yeah? Acceptance state is not defined. Probably we should edit it like to the final state. Any other questions? Did you manage to distribute the workload between the team members?
Yes.
Yeah. Okay. You need to do it soon. Okay.
It's to give the knowledge.
Yeah. Okay. 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 Good. Good. So also we like it's a mix of teams, right? It's a mix of team members.
Yeah.
So how is that working out for you?
It's interesting to cooperate with other people from our group.
Okay, that's good. Yeah, I remember at MSAT, I mean, obviously your industrial project team becomes like your family, but it's also good to cooperate with others, you know, because at MSAT, you can always learn from your classmates, learn something good. Okay. Any more questions?
Could we move our deadline, please?
Like, I don't, let's check what is, I don't like this moving of deadline, to be honest. Because
Oh, I like it. Sorry.
Yeah, so let's see what is happening now.
Now it's a Tuesday. And Thursday.
Move deadline. You have nothing on Friday, right? Oh man, this is like, you know, like this bad for your discipline, to be honest. I mean, I understand that you want more time, but like it's, yeah. No, let's keep it as it is, because it's like if I always keep delaying, then there is no motivation to finish it in time, right? And people who do it on time don't get rewarded for it, right? So yeah, let's keep the discipline, guys. And
Okay.
yeah. Let's try hard. Yeah, let's try hard. Because generally speaking, like MSAT, we are like, if we can cut you some slack, but we're watering down the MSAT experience. I remember Mansour is saying that, like, you're late 5 minutes, your problem, you know. Basically, like, this is how MSAT was for them with this Carnegie Mellon experience. Like, no excuses, you know, deliver results. That's it. We don't care about this, that, you know. And they were even saying that, you know, that breaking a leg is not an excuse to not come for exam, you know. So breaking a bone is not, unless it's your neck, you know, that's kind of the stuff. And they lived by it, you know. And it's funny that on one hand it seems over thing, but then it puts you into this mentality, you know? And you remember it, yeah, like, oh, you remember how we submitted 1 minute before deadline and almost died. Okay. So, okay. I think any more questions about about your assignment or about that?
About that, you just said that there can be some commentaries.
Somewhat.
Some commentaries. So we're not used to it, but can you just
look here? Approve request. This is natural language. In the assignment, you will get subtracted points if you don't provide natural language commentary. Because when you're making it, you're like having all these nice thoughts in your head, right? But when I come, what's the problem of natural language? What's the problem of natural language? Ambiguity. So natural language by itself is not good enough. What's the problem of mathematical notation? Yeah, hard to read, you know. I mean, like, because it's not human language, right? It's not supernatural for us to read mathematical notation. So it makes sense to provide some natural language where you kind of understood the ideas and then give the very precise definition of what you meant here. Together, they work very nicely. If you add some graphical notation to it, then you have the whole range of things. And this is how you deal with stakeholders, right?
Well, it's not requirements, right? It's assumptions, your thoughts about implementation.
You can mention assumptions, but what these guys do, this is one of the best teams I had last year, right? They declared all the assumptions here. We assume that it's possible, blah 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 blah. All the assumptions at the beginning. We have this year, like for example, for midterm. Several students also submitted assumptions in a separate file. Very good to do. Very nice thing. I gave them extra points for it because you state things clearly, you know. Then when you stated it here, you are describing what is happening here more. You're not stating even the assumptions, even though you could, right? Here, like for example, the fact that a natural set of natural numbers includes 0, I would state here as very important fact. But in terms of here, I would rather describe what is happening. Okay, so for example, is an operation that adds a request to an existing campaign. This operation requires a request that will be added to the request collection in the campaign. Consequently, the sum of active requests, sum of all amounts, will be increased as well by the amount in the request. And this is what exactly happening here, you know. Like, even though this description, I don't like it, mechanical, you know, they did it because they knew I'm going to subtract points. As a good specifier, you will provide something readable, you know, something that more better written. That's why, for example, it's important for specifiers to state their intent clearly and what you mean. It's good to have like good language skill, but also what Bertrand said. If you think through your requirements in terms of formal implementation, it gives you a formal specification, it gives you some way of thinking, and your natural language requirements become more concise, more precise, because that's the way you think, and you can go back and forth. You remember last time we talked about, I asked you the quiz, what is formal picnic? Formal picnic is when you go into formalism at certain points of your requirements to make them more precise, and you can go back and forth. You can go to from English to formal and back to English to improve your natural language specification. This is what the article describes and gives examples of it. Also, like, for example, this one, it's quite close already, you know, like to because I first thought about the formal specifications, then written it, it's somehow concise, you know, and then also thinking, but obviously still natural language, even if you're trying to write it very nicely, it's gonna have some drawbacks. Okay. Any more questions? Okay, I think let's have a quick look at what else we have. Okay. So this is the event-based system that I wanted to give you today. Should we go into it, or do we have anything else to do? Do we have anything else to do? Yeah, let's leave it for the next time. It's not a good time to go into it now and break it. Yeah, I don't have anything else to give you today then. Let's wrap up today. Okay. Thank you guys. Have a good day.
See you. Goodbye.
Bye.